Hi, and welcome back. Today we'll look at the impact assessment stage of the LCIA framework. The life cycle impact assessment allows us to understand the magnitude and significance of the environmental impacts associated with the product we are evaluating. The life cycle impact assessment is applied to the list of emissions created and resources required throughout the life of your product. In other words, the impact assessment is applied to your inventory results. Once you have your inventory results, you will realize that it is quite a long and extensive list of emissions and resources used. It is also difficult to determine which emissions and resources used for your specific product are most detrimental to the environment. Bear in mind that the inventory results include lots of details. For example, the quantities of compounds released into the environment and the quantities of different materials taken from the environment. Also, the environmental compartments into which these compounds are released and the various environmental compartments from which the resources are taken, and so on. Our impact assessment allows us to understand the extent to which these exchanges contribute towards eventual unwanted impacts. There are 5 steps within the impact assessment phase, starting with choosing a method, followed by classification, then characterization, normalization, grouping, and weighting. We will go through each of these steps. First, we need to choose the most appropriate impact assessment method. In terms of impact assessment methods that already exist, we are spoiled for choice. There are many. The choice of impact assessment method depends on the purpose of the LCA defined in the goal and scope stage. The impact assessment method includes a selection of impact categories. Impact categories are categories of unwanted impacts that are harmful to humans or the environment. Examples of impact categories include climate change, ozone depletion, or toxic chemicals in the environment. Classification matches the various substances in the inventory to the appropriate impact category. Characterization is the next step and involves converting each total quantity per substance and per environmental compartment into its contributions towards an impact. So, for example, CO2, methane, and nitrous oxide are all atmospheric greenhouse gases which contribute towards climate change. The total of each of these substances released into the atmospheric compartment needs to be converted into their global warming potential. We use a different factor for each substance. So, for example, CO2 is 1, methane is 25, and nitrous oxide is 298 when we consider a time horizon of 100 years. Global warming potential is therefore the characterization factor. Once each of these different substances is characterized, they can be added together to get an idea of the extent to which our product contributes to climate change. Of course, there are many more substances than the 3 mentioned here that contribute to climate change. The same applies to the other impact categories as well. In LCA, we also make a distinction between midpoint indicators and endpoint indicators. Try to think of eventual impacts being set about by either the release of emissions or extraction of resources. Once this process is initiated, a chain of environmental mechanisms and events come into play. We've just been discussing climate change due to the release of CO2, methane, and nitrous oxide. In very simple terms, these chemicals trap radiation from the sun in the Earth's atmosphere. The cumulative effect of this is global warming. Global warming may lead to more frequent extreme weather events and eventual climate change. In turn, people are affected by these changes. The midpoint and endpoint distinction allows us to choose where in the chain to focus. The closer we are to the initial emissions or resource extraction in terms of quantifying the impact, the more certain we can be of our result. In this example, contribution to climate change would be a midpoint. Years of human life lost as a result of climate change would be an endpoint. Once we have our characterization results, there's still a difference in units and a difference in scale between impact categories. The next step is then normalization. Normalization ultimately allows us to compare different impact category results. As the term suggests, normalization is a comparison of the characterized results to a norm. In LCA, the norm is the damage caused to the environment by the average global person per year. The average person, for example, consumes a bundle of goods and services in a year. All the processes required for this bundle of goods and services contribute to climate change, ozone depletion, toxic chemicals in the environment, and so on. We can then convert our impact category results into the number of people that it is equivalent to. So, for example, we know that the average person produces 7 tons of CO2 in a year. If our climate change impact category result is in the unit CO2 equivalents, we can divide it by 7 tons. This will tell us how many people our product's climate change impact is equivalent to in a year. After normalization, you still have results from different impact categories. They're on the same scale, number of people, but it might still be difficult to compare alternatives or make a definite decision. In this case, you might want to consider aggregating or grouping the different impact categories into fewer general groups or a single index. Another way of making the results more manageable is to weight the different impact categories. However, according to ISO, weighting cannot be used to compare alternative products or services. We can choose a weighting factor for each impact category based on monetary values, policy targets, or expert opinion. Once you have your impact category indicator results in an understandable format that matches the goal and scope of your study, you are then ready to move on to the interpretation stage. As a take-home message, try to remember that the impact assessment is applied to the results of your inventory model. See you next time.